Start record because that's seemingly what I do. I keep forgetting to hit record there. But at any rate, yeah, so let's jump right into Crosstabs. Again, this is basically a summarization of categorical variables or categorical data. Again, you'll be using two categorical variables, and what we're going to use today, just to summarize some data from the beginning, is employee data. And so I'm going to write down here, the first data we're going to look at are gender, job category, and then we'll swap it out and put in minority status. Okay. All righty. So let's fire that data set up. And I'll give you all a couple of seconds.
Dr. Munn, can you repeat what was on that last slide, the variables again?
Sure. Gender, job category, and minority.
Thank you.
And what was the data set again? Which number?
Employee data 12.
Thank you.
You're welcome. All right, so just as a quick look here, who can point out the categorical variables here? There's a couple of ways that you can identify them, but who can point them out? We have 4 on this data set, but yeah, where are your categorical variables here?
Minority, job category.
All right.
Gender.
And gender. And for some reason it has education as a ordinal variable here. I'm thinking that it's probably miscategorized. I think this is more along the scale. If it were, less than high school and, in high school diploma, then that would be categorical. But as it is, you're absolutely right. Thank you very much. We are taking a look at minority, job category, and gender. So let's go to analyze. We're going to go to descriptive statistics, and then we're going to go to crosstabs. Okay. So let's put job category in the row. All right. All right. So we'll click that and that go over to row, and then we're going to go put gender in column. Then we'll go over here to display clustered bar charts. And since all we're doing is summarizing the data today, there's no need for us to put statistics or look at the cells specifically right now. We'll click OK.
Dr. Munn.
Yes, sir.
You are in a really good flow. I hate to do this to you. Can you let me in on my?
No, it's all good. I got you there.
All right, thank you.
Not a problem. All right. So what we see here is we have our descriptive statistics here, and again our crosstabs here. Okay. All right. Will someone volunteer to summarize these data for us? Taking a look at the case processing summary here. Who can read that for me? It's really only one piece of data there that's important. What does that tell you?
The number of people in the research.
Yep,
data.
that's right. That's right. The number of cases. And so we have no cases missing. All right, anyone jump in here? What do we take here from the cross tabulation table?
There's 206 clerical
Mm-hmm.
and no custodial, 10 managers, or 206 females.
Mm-hmm.
It tells us the female male breakdown and then the total. So 206 female, 157 male clerical for a total of 363.
Mm-hmm.
And then no female custodians, 27 male and 27 total. 10 managers are female, 74 male, and 84 total. And then it gives us total female, male, and out of the total. So 216 female, 258 male, for a total of 474
Great.
employees, which is the sample or the.
What does it tell us about leadership in the company?
That more men are managers and women do the clerical work.
Mm-hmm. That's right. That's right. That's right. And we see it here in the bar chart. This would be an incredible piece that you could literally copy or paste copy as an image or export out to your Word document and put it directly into your dissertation or paper or journal article that you're writing. So one thing I really do love about SPSS is its ability to export these data tables, and if you are taking it to the next level. All right. So yeah, that's that. That's pretty easy. So let's add a layer here, and I hope I'm doing this right. I think I am. We're going to go to Crosstabs, and we're going to leave things as they are, but then we're going to put in minority classification as a layer, okay? And then we're going to click. That's all we're going to do. Just going to move minority classification into the layer here, and we're going to click OK.
Now, how did you do that again?
Sure. So I just went back to Analyze. I went back to Descriptive Statistics. I went to Crosstabs. And all I did was I left the employment category or job category in a row. I left the gender in the column, and I put the minority classification here in the layer. And what it does is it sorts everything out and adds that dimension of data to what we've already taken a look at, okay? So, in more politically correct terms, we would use this as white and non-white, right? Yeah. So let's take a look at these data. Let's take a look first at whether or not at the yes category with regard to minority classification. Did you get that, Mr. Fred?
I did. Thank you.
Perfect. Great. All right.
Dr. Munn, is there a difference for what you put in the row and column? I just want to make sure. Can you just put anything, any variable in the row or any variable in the column, or does it have to be a certain order?
No, they do not have to be a certain order. No. Yeah, you could put gender in the column or gender in the row and put employment category, job category in the column. Now, obviously, we're putting minority classification here in the layer because we're wanting to take a look at how it breaks down from that angle. But you can really mix them all up and get sort of different perspectives. It's all how you want to read the data in this situation. So my interest was sort of seeing how. Hypothetically speaking, how minority status looked like on top of all of this. A lot of times we ask, so what does race have to do with this? Or what does race, how does race color, these breakdowns or these test scores and all these things? And this is just a good way of sort of, at a glance, looking at how, race has an impact on these data. And so I have had a chance to break this down here. So let's take a look at yes, so minorities in that term. All right, so we see clerical work. We see what looks like a lot of non-white minority women are doing clerical work. How many non-white clerical women do we have here?
40.
40.
40.
Mr. Mathis, you look like you had a question there.
No, I would, because you were saying non-white. I was like, non-white equals minority. I was just.
Yeah, let me just go with minority. I don't like using the term minority. I was lazy and didn't change it in the data set. Yeah, so minority clerical women is 40. Minority clerical men is what?
47.
Okay, and obviously we never had any female custodial staff, so that remains 0 as well. But for minority custodial men, it looks like there's 13, and that's not significantly different than non-minority custodial men, right? How many non-minority custodial men do we have?
14.
14. But when we get to manager, that looks a little different, right?
Yes.
A little different.
That's a big.
For the men, it's a big difference. Are you looking at the no or the yes?
Yeah, so no, you're right. So when you look at the men manager, men minority manager, right? So you see that there are 4.
Okay.
There are no women minority managers. So, and you can break this down, right? So how many minorities are there total in this whole data set?
104.
Correct. And how many non-minorities are there total?
370.
Mm-hmm. So you have 3 times as many what we would assume to be whites than you do, almost 4 times really, than you do, non-minority or minorities. This is not my favorite term, but I hope you can follow.
You're working me with the no, yes, and the minority and the non-white. I'm looking at the table and I'm like, okay, yes means minority, no is, okay. I got my cup of Joe, so I'm good.
Yeah. I'm still working up. I'm still waking up myself, so to totally understand. Cool. So we couldn't make any inferences there. We couldn't say that, it was statistically significantly different. We're just summarizing data. And so what summarizing these data may tell you or may make you wonder is there an actual relationship between race and employment category? And we're going to actually ask that question later on today and work through that. So it's got you thinking now. By just taking a look at the data, and a lot of times, sometimes when you're trying to figure out a topic or something that you're interested in, just summarizing the data, from a very high level, can make you ask a lot of questions, and those questions may develop into research questions, and some that you can develop hypotheses for and be able to create your study. So. Summarizing data is very important, and also very easy to do. Okay. Any questions?
I do have a question, but it's because I missed the first part of that. I have the table, but I don't have the chart below. So I'm just guessing I missed something to click.
Yeah, no worries. Yeah, so when you go back up here to analyze descriptive statistics, crosstabs, you see this display clustered bar charts right here?
Go. Thank you, sir.
Yes, sir. All righty. And as I said, these are easily transportable. You'll just right click or right click. And you can copy it as an image. You can also export it as a, more traditional way of just saving that to a file or to a folder. So yeah. Okay, cool. Let us go on to the next one. So we've worked through that. Let's open up Serial. Did I put that in there as a, yes, I did. Let's work through Serial. Okay. Let's open up that one. My SPSS is real finicky. It won't, if I double click a SPSS file, it will not open it. But so I have to always go to file and do it this way, or it just won't do it. So okay. It appears that every variable in this data set is what?
Categorical.
That's absolutely right, which makes this fun for this exercise. So
can only be done with categorical variables.
Say again.
Crosstabs can only be done with categorical variables.
Generally so, yes. 99.9% of the time. I can't even tell you what, that's always what I have been taught. I can't tell you what instances that you can. I think there's probably some coding things that you can do to make a continuous variable categorical. So that's probably what the other 1% is. But generally speaking, it's going to be categorical. So what we're going to do here today, right now, is we're going to summarize gender and activity, okay? So what we're going to do, and you see gender here as your second variable, and you see activity level here as your fourth variable. And so what we're going to do is go to analyze. We're going to go to descriptives, and we're going to move over gender, and then we're going to move over lifestyle or activity level. All right. And I think I did that wrong, right? Because I shouldn't be saving standardized variable values as variables. So let me figure out what I did wrong here. Descriptives, crosstabs. I ain't call me out.
What was going on?
Yeah, I was like, that doesn't look right. All right, so we're gonna put over in rows. We're gonna put, we'll swap it up this time. Put gender in rows, and we're gonna put lifestyle here in columns. All right, and again, since we're not doing chi-square yet, we're not gonna touch statistics right now. And so we are going to spice it up a bit today. We'll go ahead and click sales. And we're going to take a look at the row percentages. So we'll click row percentages. And so what it's going to do is show us percentages as we move from left to right in the row. Okay. And then we're going to also click here, display clustered bar charts. And then we're going to click OK. All right, how many cases do we have?
880.
880. Does everyone see that?
Yes.
Okay, it's here in the case processing summary. This always gives you really good information at a glance with regard to your data set. It's also a good way of checking to make sure everything looks right. So if I come back over here to the data view, and I scroll all the way down, I should have 880 cases right here. Okay. So that lets me know, okay, I've got the right data set in place here, and we're rocking and rolling. All right. So cool. At a glance, since we have percentages here, are males significantly more inactive than the females? This is just a glance. We're not saying this statistically significantly, but just at a glance.
Yeah.
Are males significantly more active than females?
Active or inactive?
Inactive.
Like either.
Yes.
They're both pretty close.
They're both pretty close, yeah. And same thing with active levels. So yeah, we see the numbers here. We see 236. We see 188. But what this allows us to do is just see it takes the guesswork out. We don't have to divide 236 to 424. It goes ahead and gives us the percentage inactive for males, 55.7, right? Same thing with females. We don't have to, take, if we want to find out what percentage of females were inactive, we don't have to divide 238 times or divide 238 into 456 and multiply by 100. The percentage is right there for us, and we can kind of at a glance see, relative to the distribution of gender in this data set, how many people are inactive in each group and how many people are active. And so we see that in this data set that folk are a little more inactive than they are active, and that's understandable. Okay, so let's switch this up. Same data set. Let's swap it up a little bit. We're going to go to the descriptive statistics. We're going to go back to Crosstabs. We're going to go back to where we were. We're going to hit reset. And so when you hit reset, everything clears out. And let's see what we want to do here. So we're going to do, I want to see what lifestyle and preferred breakfast look like. And then I want to see what age category has to do with all of that. So I'm gonna put that in layer 1, okay? And then I'm gonna click display clustered bar charts. And I'm gonna go back to cells and I'm gonna do row percentages. Okay? And so I have my display clustered bar charts here checked. I have age category, I have preferred breakfast, and I have lifestyle active. And so I can go ahead now and click OK. All right, we have a lot more data here because now what we have are 1, 2, 3, 4 categories for age, right? Okay. And so under 31, what we see here, let's take a couple of seconds just to acclimate ourselves here. So under 31, we have lifestyle, inactive, and active. And then we have the preferred breakfast. Breakfast bar, oatmeal, cereal, okay? So those are our 3 preferred breakfast choices. So we're looking at younger folk here. We're gonna stay in this block right here, the first block. Let's take a look at active and how many people are active in light cereal who are under the age of 31.
51.
51, yeah. How many like breakfast bars?
58.
Mm-hmm. All right. Mrs. Higgins, I want you to be thinking of a question to ask the class from this data set. Ms. Thomas, I want you to be thinking of a question to ask the data set. And Ms. Hill, I want you to be thinking of a question to ask from this data set. And so I'm going to shut up for a couple of seconds here and let you all develop that and let you ask those questions in that order. So everybody take some time to soak in all this, to look at it, and I'm gonna let you all develop the questions, okay?
What does this data set tell us about the preferences of inactive and active people with regards to oatmeal?
Is that your question for everybody? Or are you
Yeah.
just asking me that?
No, that's my question.
That's your question? Okay.
What do we know from this data set about whether or not inactivity or activity has anything to do with oatmeal preference?
Don't like it.
It looks like if you're
It looks like they don't like it.
If you're under 31, you don't eat it at all. Regardless if you're active or inactive.
They just don't know what they're missing.
I was looking at it and I'm like, does it matter if you're
It looks like the older you are, the more you like oatmeal and you appreciate it. So they're from a different generation.
Yeah, look at the over 60. With oatmeal.
72%.
And even with the 46 to 60-year-old, they like oatmeal.
Not like the 60s though.
Yeah, not like the 60s. The over 60s, that's all they eat.
The older you get, the more you appreciate oatmeal.
There you go.
So when you're young, when you're under 31, doesn't matter what your lifestyle is, you don't typically like oatmeal.
Yep, and you see that here in this chart right there.
I think about it as, oatmeal takes time to cook. So when you're under 31, you're in that rush type mode.
Mm-hmm.
Well, for my category, which is truly my category, from 46 to 60, could the increase in the oatmeal be related to health?
That's what I was thinking.
Great question. You cannot answer that from the observation.
It's just an assumption.
So you see, so you see how the data, how just summarizing the data can get you to start thinking and asking more inferential questions.
Yes, because like from 46 and then you have the over 60, they start liking, some people start liking oatmeal.
Yep.
And I know they always push oatmeal as a health food,
Sure.
So that was just, like you said, it was just something that popped in my mind, based off of what I'm saying with oatmeal.
Taking a look at the preference of oatmeal in inactive over 60 folk, it looks like that in terms of mitigating health issues, to your point, that maybe changing their diet is the most popular factor in terms of addressing health issues. So that is interesting. So for folk who are under 31, more likely to be active, you see that they tend to eat breakfast bars and cereal and not so much oatmeal. So it's just fascinating. As I said, if you were in the literature and, just taking a look at this, it's just really interesting to sort of peel this back and, take a look at the summarization of the data. Who had the second question?
Cheryl.
Ms. Thomas.
46 through 60, that was my category. So,
okay.
Yeah, I'm sorry.
Go ahead.
I'll just go back to that question. Could the, do you think the increase with the oatmeal, how can I say this? People eating oatmeal, is there a relationship between their lifestyle, their age, and how they tend to like oatmeal as they get older?
So
Some
that's
people.
that's a very inferential question. So we can't really ask inferential questions right now because we're just literally summarizing the data. We're just putting data in different categories. We will do the
That's right.
inferential.
Everybody used the word.
Yeah, we will do the inferential once we get into chi-square. Yeah, but basically, I just wanted to see if you all were comfortable with these data, and if there was a way that you could sort of look at this and be able to ask questions based on on these summarizations. So you said your group was 46 to 60. Yeah, just take a look at this block and see if there's anything that you could ask the class in terms of that. And I'll come back to you. I'm gonna give Ms. Hill a chance to throw out her question real quick.
Okay. In what age category is
You can use any. You can use anything.
Oh, that was part of my question.
Oh, okay, my bad. Let's cut you off.
It's okay. I'm so high level over here, I'm sure. Anyway, in what age category is there the largest percentage of inactive people eat cereal?
So that's really easy if you did your chart.
You said what was the largest?
Yes, percentage in which category had the largest percentage of people that eat cereal?
Inactive, right?
It was inactive, yes.
Under 31.
No, 31 to 35.
More than 31.
Under 31.
It's under 31.
Under 31, 60%.
The young people, because they're in a hurry.
Now, can you use percentages?
But I would
here?
have thought that they would do the breakfast bar because they're in a hurry.
But younger people don't eat Nutri-Grain bars and stuff like that. You know,
Yeah.
that
True too.
They want Lucky Charms and Frosted Flakes and the new
because they're
Frosted
still in front of their TVs playing video games with a bowl of cereal.
But it'd be so easier just to eat a breakfast bar, I would thought. But
A breakfast bar is going towards that healthy side.
Before y'all start to get into why they
We are.
because I was looking at the chart and I got it completely wrong. So what's the answer?
The young people under 31, because they're at the 60% that eats.
Can you repeat the question?
I mean, 93.
Yeah, so the question was, in what age category is there the largest percentage of inactive people that eat cereal?
Okay. So under 31 is 37.1%. And then 31 to 35 is 33.7.
Wait,
You're looking at breakfast bar.
I have a question because it say 47 are inactive that eat cereal instead of 42 from the 31 to 45 age group.
But what percentage? But we're looking at percentage.
Okay, so I was right the first time. Okay, under 31.
All right. Thank you, Andrew.
Good question, Angel.
Very, very good question. So yeah, the answer is under 31 because 60% of their inactive respondents are eat cereal. Very good. Very good question. Does that make sense to everybody?
Yes.
It does.
Awesome. Okay. Coming back to you, Mrs. Thomas.
Okay. So question, in the 46 through 60 age category, what is the percentage of people who eat cereal with an inactive lifestyle?
41.
41%.
Thank you.
That's right. That's right.
Yes, 41%.
So now it seems you're able to track this pretty good. This is a pretty complex table. It's got, layers on layers and percentages, but I want you to be able to read it and obviously be able to put up to produce these charts as well. So as long as you're able to, take the time and be familiar with your data, you'll get it. At first glance, it may seem a little overwhelming, but spend a couple of minutes. Use your finger and just kind of go through, and it will definitely come to you. All right. Great. Do I want to do this one? What time is it? I haven't tested this one, so this may go horribly wrong. So let's pull up a debate and let's work through this together. All right. There's nothing like the risk of completely melting down Saturday morning to get your juices rolling. So we're going to roll with it. Okay, what I have here is our debate preferences, right? So we have.
Dr. Mine, quick question.
Sure.
When you clicked on that data set,
yeah,
how did you, like my names and things like that, they don't appear?
Variable label.
Variable.
You see this right here? The
yes,
the one is click that.
Okay.
And it should go back and forth. Does it do that?
Variable label.
You see it up here?
I don't even have that across my, oh yes, it's grayed out. That means I need to go to data view and click it. Okay, yes sir, thank you.
No problem. Okay. So all these are categorical variables again. And this is a data set with about 1,296 people and their debate, their choice of candidate before a debate and after. So a pre-test, post-test, which is pretty interesting, right? Okay, so what we're going to do is just, again, summarize the variables. We're going to go to Analyze. We're going to go to Descriptive Statistics. We're going to go to Crosstabs. Okay. So let's just take a look at gender, put gender in row, and let's put preference before the debate. We're going to click on cells. We'll put row percentages. We'll click display clustered bar charts. So just to review quickly, gender in rows, preference before debate in columns, row percentages, and display clustered bar charts. All right, those should be your 5 choices, and we're going to go ahead and click OK here. All right, so we have 1296. I think I mentioned that earlier. And we're breaking this down. We're breaking down these debate choices by gender, all right? And so I'm going to ask a couple quick questions here. Let's take a look at the bar chart, because the crosstab is great, and I hope everybody was able to get their bar chart here. But it really helps you, see right away who prefers who. Okay. So the males, what's the candidate that males prefer most?
Cruz.
Females, who do they prefer most?
Addison.
Great. And we see that, how does Bolton fare with males?
Low.
Not so much.
Low.
Worst, right? But for females, he is the second most popular, right?
Second.
Yeah, we see with Dean that they're just about the same, female, male, and female. And this is reflected here in the numbers. I won't insult your intelligence. We see that we have slightly more respondents with females. How many respondents do we have that were female?
685,
And male?
611.
Right. But still, we see that Cruz has how many males preferred Cruz before the debate? 264. And then for females, Addison was the most popular with 225. So let's go back up here, and we're just going to change one variable. We're going to go back to analyze. We're going to go to descriptive statistics. We're going to go to crosstabs, and we're just going to swap out preference for before debate with preference after debate. Okay. All right. So we see, what do we see here in this bar chart relative to the first one? Let's see if I can get both of them up here. I can't. But anyway, just using our memory.
I think people were more impressed with Dean after the debate, both male and female.
Men still preferred Cruz.
That's right.
I think
women still preferred Addison.
That's right. Yep. That's right.
And there was a decrease for Dean for women before the debate.
So let's take a look at the two crosstab tables. So we have the crosstab table after debate and the crosstab table before it. And so let us take a look at, we saw Addison. Addison was the front runner for women before the debate and after. And so let's take a look at Addison's numbers or percentages with women after the debate. So after the debate, women preferred him. 213 women still preferred him, with a 31.3% of all women. But before the debate, what was that percentage?
225.
Not quite. What was Addison's percentage?
Oh, I'm sorry.
You're fine.
32.8 with the females.
So what actually happened with Addison?
He actually went.
They went down.
He went down. Right. Yes.
That's right. And it looks like, based on the chart, that they increased, and in actuality, it did not. It's 213, so she actually lost support. Let's go ahead down the line here. 161 for Bolton, which brings his percentage to 23.5, and this is again after the debate. What happened with Bolton before the debate and after the debate here? With females.
Decrease. Yes.
That's right. That's right. So we went from 185 and 27% to 23 through to wait, make sure I got this right here. Yeah, 185 and 27 to 161 and 23. So clearly somebody gained something, right? Someone had to gain ground, because we still have the same amount of respondents, right? So let's move on here to Cruz. Cruz here after the debate was 178 with 26% of all women voters, right? All right. And here and before the debate, it was 177 and 25.8. So looks like Cruz gained one voter, right? And we see here Dean started out with 98 supporters with women, right?
Right.
And he went up to what did he end up with females?
133.
133.
So he was the one that gained the most with females. Now let's see if that corresponded with males, right? So right now, let's take a look at Dean before the debate, the pretest, and that was 110, and the percentage was 18. What do we see down here?
148,
Right.
percentage 24. Yeah.
Right. So we see here right away that Dean impressed more people, apparently, just by looking at it. Because in both data sets, he gained the most. Now, it doesn't seem like it very, here. Well, I guess it does a little bit, but I think being able to pour through this data and take a look, we're able to infer a couple of things, and we want to flesh that out a little more. Okay. With chi-square. Okay, so I think we have done a good job going through crosstabs. I hope all of you understand the summarization of data and how illuminating it can be. But chi-square takes it to the next level. Chi-square allows you, it's a test of independence, and it asks you, is there a relationship or association between categorical variables? So the same variables we were looking at and the same things you were starting to infer, you can start to see if there is a relationship. And so there's a lot of interpretation that we have to have. Chi-square, again, can only compare categorical variables. It cannot make comparisons between continuous variables and categorical variables. It's an index of actual results compared to those that are expected by chance. And so, here's an example of a hypothesis for a chi-square analysis. If you suspect that there's a relationship between the gender of a principal and female student achievement, you would state it as the null. And if the data pieces came back to say that there was a relationship, you would reject the null hypothesis. Okay, so there's no relationship between gender and female, and if these data, come back to be, these data come back with a 0.50 or below statistical significance, and none of the other parts of the test violate the assumptions, then you reject the null hypothesis, because the null hypothesis is apparently not true. There is a relationship between the gender of a female principal and female student achievement. Now, in the instance that p-value is above 0.50 and things are violated within that data set, then you would fail to reject the null hypothesis. You can't reject the fact, and this has to stand. And you would say that there's no relationship, that you can't reject that null hypothesis. Here's another example of a chi-square analysis hypothesis. The level of wealth the county influences the leadership style of a superintendent. And so, let's just take Hope County. Let's just say that, low wealth county has autocratic, and high wealth, laissez-faire, and another high wealth county like Wake is, more of a democratic approach. You use the same thing. There's no relationship between the level of county wealth on superintendent leadership style. And so if you ran the analysis and these data and everything was significant, then you would reject that null hypothesis and say, hey, there is a relationship here. I can't accept this null hypothesis, so I have to reject it. Okay. Here is just here's some data points that are useful whenever, so say you do your dissertation and there are some things that you want to learn a little bit more about chi-square. Here is sort of just a data slide. The one thing that I will, the most important thing that I will do, that I want to lift up today, is to examine the significance level, the p-value. That is the most important statistic in a chi-square test. Chi-square values are important, and higher chi-square values, obviously indicate that there's a significant relationship. But none of that matters. You can have the highest chi-square value in the world, but if your significance level is above a 0.05, it doesn't matter at all. So the most important part of a chi-square test is the significance level, and that's pretty much true through anything that we do moving forward. We'll see in t-test and in analysis of variance that if the significance level is above a 0.05, then every other check also fails as well. So there are 2 or 3 for t-test and 2 or 3 for ANOVA. But you can pretty much say, without a shadow of a doubt, if the significance level is out of whack, then you can just go ahead and fail to reject the null hypothesis, because whatever you're looking at is not statistically significant. There's the relationship there. So again, when we're running the test, we generally state the null hypothesis, as I did earlier. We examine the significance level. The significance level is less than or equal to 0.50. There is a significant relationship between those 2 variables. So let's just say we're examining gender and hair color, right? 2 categorical variables, and if we run the analysis and the significance level is less than 0.50, then there is a significant relationship between those 2 variables. And then you would reject the null hypothesis and state that there is a relationship between the independent variable, gender in this case, and the dependent variable, hair color, which is absolutely ridiculous. I just pulled it out of the air today. If the significance level is greater than 0.050, then you state that you would fail to reject the null hypothesis and that there's no relationship there. The relationship that you thought moving into this test just doesn't exist, and you fail to reject the null hypothesis. So let's go back to our data set 12, employee data. And again, we're going to be looking at gender, job category, and minority status. And so now we're going to really be able to start to answer the questions, right? Between, okay, is there actually a relationship? We look at these numbers, and these numbers look really interesting. Is there actually a relationship that I could write a paper around, that I could state in research? And so we're going to do that real quick. So what we're going to do is we're going to go to analyze. We're going to go to descriptive statistics.
Dr. Munn, right quick, which data set are we using again? I'm sorry.
We're using employee data 12. Okay. Let me know when you get that one up.
Go ahead.
All righty. Cool. So what we're going to do is we're going to go to analyze. We're going to go to descriptive statistics. We're going to go back to crosstabs. Let's go ahead and reset. Okay. So I said gender and job category, right? So we are going to put gender in the row, and we're going to put job category in the column, okay? Now, since we're doing a chi-square test, this time we are going to go to statistics. And we're going to click the very first one, chi-square. And then we're going to click phi and Kramer's V, because we want to see what kind of effect size, what size of an effect, if this is statistically significant. So if this is statistically significant, We want to see what kind of, what size of an effect gender has on employment category. Who can tell me what the independent variable is here?
Gender,
Right, it's having an effect on what?
job category.
Absolutely. Okay. We can go to sales. What we want to do is click expected, okay? And what expected is going to tell us is this is the expected count, right? This is the count that we would expect if there's no relationship between these two variables, right? And so if your observed count is different than your expected count, then what you're going to generally say is, okay, there is a relationship. If they're about the same, then there's likely not going to be a relationship between these two variables. And again, what we're trying to figure out is there a relationship between gender and job category?
So do we uncheck the observed or do we leave it there as well?
No, you keep both. Yeah, observed and expected. Mm-hmm. Excuse my dog, everybody. We're gonna leave display clustered bar charts unchecked, and then we're gonna click OK. Okay, how many cases do we have here? What's our N?
474.
That's right. So let's go down here to, let's go ahead, and this is very, very important. This is the first thing that I do, right? I go down to chi-square test, and I see asymptotic significance, and I look for this value right here. If it is less than 0.50, then it is significant. Is this less than 0.50, 0.050?
Yes.
Yes. Okay. And so is our effect size as well, okay? So cool. So we know that off the bat that there is a relationship between gender and job category. Another way to determine that this is the case is taking a look at our observed count and our expected count. And again, expected count is a count that we would expect if there were no relationship between gender and employment category, right? So if this were 166 and this, clerical was 166 and custodial was, 13, then we're going to probably see that there's not much of a relationship. But now there is a relationship. Something is going on here. So we can, right off the bat, by looking at this and taking a look at this, we can reject the null hypothesis and state that there is a relationship between gender and job category. So if you wonder if there might be some bias here with regard to the heavy amount of clerical with women, then you can say that. And in particular, the relationship, or what we've observed in our previous summary between men and females with managerial jobs. And the literature backs that up. And that's why when you do a literature review and you state your problem in the beginning of your dissertation, you're making these points. The literature says this, the literature says this is what I've observed. This literature says this. And then you get into the math, and and you get hopefully very current data, and the math backs up what you said in your literature review and in your chapter 1. And so you're just reaffirming your point. Yes.
Can you go back to, I guess it's where you're highlighted down there, the chi-square test table. Now looking at that, tell me one more time how you looked at that. And
Yeah, so the most important value here is your asymptotic significance two-sided. If that number is less than 0.050, which
Okay.
it is in this case, then it is significant. I'm not very concerned with the chi-square value. That doesn't tell me what I want to know. What I want to know is there a relationship between gender and job category? And by looking at the difference between count and expected count and looking at the asymptotic significance, I can see right away that this is statistically significant. Now, if I want to see what kind of effect, how strong of an effect that gender has on employment, I come down here to 5. Since this is a 2x2 table. Nope. This is not a 2x2. This is not a 2x2 table. So when this is not a 2x2 table, if this is 2x2, so I had 2 dichotomous variables, then I would use the phi statistic. But since this is a 2x3 table, male, female, clerical, custodial, and manager, then I would use Kramer's V. Now in this situation, the values aren't different, right? Both of them are 0.409, okay? So now we're going to move over to our Morgan book, IBM Statistics, this book right here. Now we're going to go to page 102, okay? Now, what we're looking at here is table 6.5, and we're looking at the interpretation of the strength of a relationship. And what we want to do is look at the R family and look at the first column, R square, R, and phi. You know, those of us who recognize the greatest fraternity on earth recognize that it is bound together by the phi. So, you know, I had to, I'm sorry. But at any rate, we see here that our Kramer's V value is what? What's our Kramer's V value?
Is it 1?
No.
On this chart?
On the SPSS. On SPSS.
0.409.
0.409. Now, when we look at R square, R, and phi, where does that fall? It falls right here in
page 102.
102. And so what we're looking at is small or smaller than typical. That is 0.01 to 0.10. We see medium go from 0.09 to 0.30. And I'm gonna stop there and make sure everybody's tracking with me. Everybody with me here?
No, sir.
Okay.
No, sir.
All right. What's your question? Where are we at here?
I know for me, on page 102 in that book, I don't know where you are. There are so many things I can click on, figures and charts.
Oh, do you have an
ebook?
Oh, you have an ebook. Okay, what you need to do is search for interpreting effect sizes, because ebooks do not track with regular.
Okay, thank you.
No problem.
Thank you. I have an ebook too, and I was getting petrified.
No worries. Yeah, you might want to search table 6.5 or just interpretation of the strength of a relationship. For those of you who have regular books, are you good?
Yes.
Nice. For those of you who have ebooks, let me know when you find it, because this is a very important tip. You'll want to bookmark this. We're going to be going back to this table for the rest of the semester.
What's the title of that table to make sure I got the right one?
Yeah, interpretation of the strength of a relationship.
Okay.
in parentheses effect sizes.
Does it have on the top the D
133, I
family?
think.
Say again?
Does it have on the top, does it say the D family and the R
Yep.
family? Okay.
Yep, that's it.
That will be on page 133 if you have an ebook.
Yeah.
Thank you for that. I'll note that. Okay. So what we're looking for is the R square, R, and phi table under the R family. So just go ahead and highlight that if you can. And what we're looking for in this situation, since the Kramer's V statistic is 0.409, we're looking to see what kind of effect or how strong of effect gender has on employment category, okay? So we see here, starting with small or smaller than typical, we see 0.01 to 0.10 is small. We see 0.09 to 0.30 is medium. We see 0.25 to 0.50 is large. And we see that 0.49 to 0.70 is much larger. And if it's larger than that, then it's really, really, really large. Okay. So everybody follow that?
Yes.
Great. So if this is 0.409, what kind of effect, what size of an effect does this have?
Would it be large?
Yeah, large or larger than typical. Okay. So we can say right here, based off of these data, that there is a relationship between gender and employment category, and there's a way to write this up. In your chapter where, let's see here. Yeah, in chapter 8, they show you how to write this up, particularly on page, give me just 1 second. Well, for those who have books, regular books, it's 136, and it's problem 8.1, chi-square and phi. And so what I really love about this book is that it shows you step by step how to how to work through this. It's doing the same thing I'm doing. And it will show you exactly how to write it up in a way that would be acceptable in a dissertation or a journal. And so you can literally take the words, and there will be an assignment coming forth near the end of the semester where I am going to ask you to refer to this book, basically do a statistical test and be able to write the interpretation. So yeah, just thumb through chapter 8 and look at the example of how to write up the results for problem 8.1. And it'll tell you how you can interpret and write up this data for someone to be able to read and analyze. But yeah, that's chi-square in a nutshell. I mean, we are basically examining if there's a relationship between two categorical variables. The more cases, and I can tell you right now, given the amount of cases they have here, 474, if there was a relationship to be had, it was going to be very strong. It was going to be we were going to know definitively if there was a relationship. So let's go on down and ask the next question, which is there a relationship between minority status, same data set, and job category? Okay. So we want to swap out independent variables here. Okay. instead of gender driving the train, we want to see if minority status drives it. So we're going to go to Analyze, Descriptive Statistics, Crosstabs. We're going to take gender here out of the row, and we're going to put minority classification in there. Let's go ahead and click Display Clustered Bar Charts. And go back to statistics. They should still be the same since we did not reset.
What's in columns?
Employment category. Mm-hmm.
I missed a lot in 20 minutes.
Oh man, no, I'm sorry. Well, this is all being recorded, so it'll be up.
Was there a layer?
No layer.
Okay, good. Okay.
No layer. Yeah. So again, statistics are chi-square and phi and Kramer's V. And sales are, when you go to sales, be sure that observed and expected are both checked. And we're gonna, this time we are gonna display cluster bar charts. We'll click OK. Okay. So the first thing we do is what? We want to see if the significance level is below 0.050. And when we look at the Pearson chi-square value and we look at the asymptotic significance, we see that it is indeed below 0.050, okay? So we can right off the bat say, hey, there's a relationship here, all right? So let's go here to minority classification. If there were no relationship, we would expect a count of 283. If there were no relationship with minority classification and clerical work, we would expect a count of 283. We instead get 276. We would expect a count of 21, but you know, we actually got a count of 14. We would expect a count in terms of managers of 65.6, and we actually got 80. So what we're seeing here is that for folk who are not minorities, they actually are overproducing in terms of managers, right? We have 80 non-minority managers, but if there was no relationship between minority status and job category, we should have expected 65.6, but that's not what we got. If there was no relationship between minority status and custodial work, we would expect for non-minorities to have 21. Instead, we have 14. And if there was no relationship between minority status and employment category, in this case, clerical work, we would expect 283. Instead, we got 276. All right. Now, coming down here to if you are a minority, we would expect clerical work, we would expect for that count to be 79 or roughly 80. We got 87. We would expect, given the amount of minorities in this company, that if there was no relationship, if there was no relationship between minority status and job category, there would be about 6 custodial staff, but they're actually 13. And here's a really obvious point here. If there was no relationship between minority classification and employment category, we would expect to have 18 minority managers. How many do we actually have?
4.
Okay. So we see that there is very likely something going on here, and that's what the math picks up. That's what SPSS picks up for us. And so we can say, without a shadow of a doubt, that we would reject the null hypothesis that no relationship exists between minority classification and employment category. And so the next question here is what kind of size there is. And so this, again, this is a 2x3 table. So we would not do 5, we would do Kramer's V. And so going back to page 102 or 133 and looking at this table, what kind of effect size is this?
Medium or typical?
That's right. So there is a medium to typical effect size. There's, you know, there's definitely something going on here.
Dr. Mike,
yes.
I will go back and watch this recording, but am I to assume that you only use 5 if it's a 2x2 table?
That's absolutely right. Yeah, the 2x2 you use 5. If it's anything larger than 2x2, you use Kramer's V.
Okay.
And again, what I want you to do, I'm not sure if I put it on the syllabus. I want you all to go to 8.1 or chapter 8 in the text. And I want you to read through 136. I want you to definitely do 8.1. And then I want you to do, actually, I just want you to read all of chapter 8. That's the safest thing to do. Because it will reinforce what we've gone over today. All right, cool. So let's move on to the next example. Is everyone tracking with me? Everyone following?
Yes.
Any questions? All right. So yeah, we've gone through cereal already, and we had some questions about cereal. So let's delve into it and see what kind of relationships we can glean from cereal. So let's pull up the cereal data set.
Okay.
Okay. Now, we wanted to know, in general, I think we were pretty interested to see, I think we were interested to see whether or not there was a relationship between age category and the type of breakfast, right? I think that's the thing that is most pertinent on everyone's minds, the relationship between who eats cereal or oatmeal or breakfast bar. So what we're going to do is go to analyze. We're going to look at those two variables. We're going to analyze descriptive statistics, crosstabs. We're going to reset, and we're going to say that we think the age category is our independent variable, has an effect on what?
Preferred breakfast.
Preferred breakfast, correct. So then what we're going to do is go to statistics. We're going to click chi-square. We're going to click phi in Kramer's V. And we're going to click continue. We're going to click display clustered bar charts. We're going to click observed and expected here. Click continue. All right. So what would our null hypothesis be here? How will we state our null hypothesis?
There's no relationship between age and the type of breakfast people prefer.
Absolutely, absolutely, 100%. Okay, so we're ready. Now that we have that null hypothesis in the back of our minds, we're ready to go ahead and click OK. All right, and let's go find that output. Okay. So we have about 880 people who have responded to this data set, or to these questions in the data set. And what we have here we're going to go ahead and go straight to chi-square test. And what do we have here in terms of significance? We've been hitting it out of the park with significance these last couple of examples. But we have a significance level that is what?
There is a relationship.
There is a relationship between age and not job category, but age and preferred breakfast. And so we're going to go back over here and just reaffirm this in our mind. Okay. We would expect if there were no relationship between age and preferred breakfast, we would expect that folk who are under 31, 47 of them would prefer a breakfast bar. But in actuality, gosh, we have 84. Same thing with oatmeal. We would expect 63.8 or 64 folk under 31 to like oatmeal. Only 4 do. So we're immediately seeing, and I'm not going to insult your intelligence, you can immediately see the difference between expected count and what we actually got. And what we actually got is what really drives whether or not there's a relationship here. Okay.
Dr. Moon,
Yes, ma'am.
what determines the expected number, the expected count?
My guess is that just based on numbers, I think they just base it on the fact that they're splitting this into I think it's just numerical based on how many folk are under, in this instance, how many folk are under 31. And so they're just splitting it into evenly. They're distributing it evenly. And so what the test is saying is that, there's nothing going on here. This is how many people should fall into this category based just on numerical distribution. But when you have something else going on and affecting that distribution, that's what the test picks up. It says, oh, that's different based on what we should expect. Therefore, there's something going on here, and I'm going to measure that in effect size and significance. And that's what this test does. It measures, against what we should expect. And like I said, I think it's literally it's just division, and they're just seeing, okay, we have 181 people under 31. And we're just going to split it up based on that. I literally think that's what it is. Don't ask me, don't quote me on that, but I'm thinking that's what it is. And when the actual number is different, that's what the test is measuring. Does that make sense?
Yes, sir.
Okay. So we see here that there is a relationship. We see it in the numbers, pretty significantly so. I'm looking at 60, over 60 to you all's point. In oatmeal, the expected count would have been 92, and we actually have 185 folk who like oatmeal who are over 60. So there's something definitely going on there. All right, so we're going to go over here to symmetric measures, and since this is a 2x3 table, we're going to go with Kramer's V. And tell me what kind of effect size do we have here based on our chart on page 102 or 133, 6.5 table.
So we use Kramer's V?
You use Kramer's V, and that gives you a score of what?
0.419. So it's larger than typical?
That's right. So we transfer that 0.419. We look over here on this table, and we see that falls between 0.25 and 0.50. Okay. And as we scroll down, we see the bar chart, and that's a beautiful thing. Oatmeal takes the day. All righty. It's heavy stuff this week. How y'all feeling?
When's the recording gonna be up?
The recording will be up, hour after YouTube has to process it, but it's going to go up.
All right.
If you have any questions, holler at me. I'll be happy to ask.
I don't even know what to ask. Like, I left and y'all were like, how many people are in this row? And I came back and y'all were like, Kramer's V and phi. And like, I don't even know what to ask.
So Kramer's V and phi are the effect sizes.
Yeah,
and they
you
tell
don't even have to, Dr. Moon. I had to leave, so I don't even want to put that on you. I'm going to watch the recording, and if I have any questions, I will hit you up via email.
Okay, cool. All right, so we're going to go and we're going to break down. We're going to see if there's any relationship here with debate. So we're going to open up that debate data sheet, and we're going to see if there's any relationships between age category and gender. So we saw when we looked at the numbers, when we were summarizing the data in the crosstabs, we saw some pretty interesting things. But now we want to verify if these relationships or these things that we observed in the numbers are actually statistically significant, okay? So we got two null hypotheses here. There's no relationship between age category and candidate preference in all the political science literature I've ever seen. That is always going to be false. You're always going to reject that. And there is no relationship between gender and candidate preference after the debate. So we're gonna take a look at this and see if this is actually true here. So we're gonna pull up this data set, and then we're gonna go to Analyze, Descriptive Statistics, Crosstabs. Let's go ahead and clear everything out. Let's hit Reset. All right, so we're going to assume that there's a relationship, or personally speaking, we think there's a relationship between age category. And I don't really think theoretically it matters which one we use. But let's go with preference before the debate. Okay. All right. So then we're going to go to statistics. We're going to click on chi-square. We're going to click on phi and Kramer's V. And then we're going to click OK. And then we're going to click on cells. And then we're going to click on expected. Okay. All right. And then we're going to click display clustered bar charts. And then we're going to click OK. Okay, so right off the bat, we go down here, we look at our case processing. We knew that there were 1,296 respondents. And we go down to chi-square test, and the first thing we always check for is significance. And we see here, again, that this, and you're not going to always see this in data set, so we're knocking it out of the park today. But again, this data set is significant, all right? This relationship that we think is there is indeed significant, okay? So there is a relationship between age category and preference and candidate preference before the debate. And just a quick scan of these numbers show that to be the case. We would expect that there was no relationship to be 58 people under 31. Actually, there's 70, right? So we see that there's a relationship there. The only thing left to do now is to see how strong it is. Now, again, this is a 1, 2, 3, 4 by 1, 2, 3, 4 table. So this was not, you cannot use phi, you have to use Kramer's V. And so as to determine the effect size. So let's go back over to page 102 and see what kind of effect size there is.
Dr. Munn.
Yes.
What's my question? This table in the book, we use that both for phi and Kramer's?
Yes.
Okay, just our output table tells us whether to use phi or Kramer's V.
Oh, wait. Yeah. That's correct.
But we always use in this is this Morgan? We always use this table to show us strength of a relationship.
Yep. If we were looking at the strength of associations, so we're going to be looking at the strength of differences in means. We'll be looking at the D table. But for this relationship, anytime there's sort of a relationship question here, we're going to be dealing with R square, R and phi. Are you serious? I'm sorry. Okay. So yeah, so this has a what kind of effect? Somebody else was saying something.
Well, I was just going to say, I think that was the same value that Maurice said earlier was typical.
Right.
Okay.
Medium and typical. Yep.
Medium typical.
Okay, so we've examined the relationship. We knew there was a relationship between age and debate, performance before the debate. Let's swap it out a little bit, y'all. Let's go back up here to analyze in descriptive statistics, and then to crosstabs. Let's take both of these out. And then for row, we want to put in gender. And then for column, we want to put in preference.
Dr. Moore, I have an emergency.
Oh.
I will get back to you in a minute.
Okay. Okay. Yes, ma'am. So we're going to be doing row here, and then in here for column, we're going to be doing preference after the debate. We don't have to change anything in terms of statistics, and we don't have to change anything in terms of cells. We'll leave clustered bar charts here. And so again, we're trying to figure out, is there a relationship between gender and preference after the debate? Who can give me my null hypothesis?
There is no relationship between gender and preference after the debate.
Absolutely. All right. I've gone through this a couple of times. You all tell me what's going on. Walk me through it.
So first you count whoever that was. Go ahead.
No, go ahead. Because I think I missed a step when I was. Y'all correct me on the chart. Addison, male count 140, expected count 166. I just want to make sure my data is straight.
That's what I have.
That's right. That's right.
Okay. Okay.
So the first thing we do is look at Pearson's chi-square, and we see that p-value is below 0.5, so we understand that there is a relationship.
Yes.
So we will reject the null.
Mm-hmm.
And we're doing that because we can then see from the data that the expected count and the actual count, we see that they're different.
Mm-hmm.
And then we would go down. This is more than a 2x2 table. It's a 2x4.
Mm-hmm.
And so we would use Kramer's V, and that value is 0.182. And then we would go to this table in Morgan, and 0.182 is a medium or typical relationship, strength of relationship.
Yep, it is a medium to typical effect size. That's absolutely right.
Medium or typical effect size.
Mm-hmm. Mm-hmm. Yep, that's absolutely right, man. Good job. Good job. Good job. Good job. Good job. That is absolutely 100% correct. The first step you take is to see if it's significant. Second step you see is just to check through the expected count and the actual count, the observed count. And then you want to see what the effect size is. And that's it. And what we've done here is to analyze the relationship between two categorical variables. Right. Okay. T-test. So we have about 15 minutes before 11 o'clock. And so we're gonna start on T-test. We probably won't get to ANOVA today. And this first one's pretty easy, right? We're moving away from categorical variables, and we're now dealing with continuous or scale variables. All right. So what we want to do here in a one sample t-test is we want to determine, you're looking at the differences in means, okay? And we want to determine whether a mean that is statistically different from a known or hypothesized population mean. So in this instance, we want to know, are NC North Carolina boys actually taller than United States boys? Or are test scores in Moore County higher or lower, or, you know, than test scores in the whole state?
So, Dr. Mo, you said a t-test, it will, you do it when you have a known variable and then a known mean and your mean, I guess.
Yeah, no, I follow you. Mm-hmm.
So you've got U.S. boys, because we know that, and then if you're gonna say, okay, my population, or rather my sample, is the NC boys. Now I want to see if these are significantly different.
Precisely.
Okay.
Precisely. I mean, that's absolutely right. And sometimes you'll look at data, and so say the mean height for NC boys from the sample that you've taken is, let's just say 55 inches. And the mean for US boys is 58. Well, you might say, looking at it, well, they're not much different. I don't think it's statistically significantly different. You can't say that unless you run that data, right? So I'm gonna show you how to do that. Okay, so we use this, to see the difference between a sample mean and a known or hypothesized value of a mean, statistical difference between the sample mean and sample midpoint of the test variable, a statistical difference between the sample mean of the test variable and chance. All right. So generally what you're going to say is that there's no relationship between the scores on the test variable. And I'm going to leave this as sort of a data slide. I'm going to sort of get into this so I can actually show you what we're talking about. Now, when we are running this test, if the significance level is greater than 0.50, there's no significant difference. Basically there's no difference. There's no difference between the sample mean and population mean. And the confidence interval cannot cross 0, and I'll show you exactly what I'm talking about. And so generally what you're saying here, the null hypothesis in one sample t-test is the sample mean equals the population mean. And if the significance level is greater than 0.050, there is no significant difference between the sample mean, and you would fail to reject the null hypothesis. But if it is lower, then you would reject the null hypothesis and say that the sample mean and population mean are significantly different. There's a difference there. Okay, we're going to ignore the t-value and focus on these two tests to determine whether or not the test is significant. And we're going to get right into it. Okay, so we're going to do a pretty simple one here. All right. Sorry. All right. So let's pull up biology, and we're going to look at height and weight. Okay. So let me, I don't think I'm going to have to go to my data and biology 101. Okay. All right, this is a pretty small data set. But we're interested, as we go to this slide, we're interested in seeing if the average height, okay, in this classroom, this biology 101 classroom, is actually statistically significantly different than the national average height of 65 inches, okay? And so what we have here are a list of data, which is going to give us a mean height, and hopefully be able, and I hope there's enough cases for us to get a statistically significant outcome if there is a significant the difference between these data. But you can imagine if this were 1,000 cases for this class, and we were able to get a mean, we would be able to definitively say that if the mean comes up to be 72 inches, that we would say, oh, well, this class is going to be much taller than the average, than the United States average height. So let me quit talking and get right into it here. So we're going to click Analyze. We're going to go to a new thing here. We're going to go to, we're going to click on Compare Means, and we're going to go to one sample t-test, okay? All right, so again, what is the test variable? What are we interested in seeing in terms of our class? We're interested in seeing what our class mean is, right? What variable are we interested in?
Height.
Height, right. So you're gonna move height over. This is a pretty easy test to set up. You just have to conceptually set it up on the back end, right? And we remember that the national average weight, if you go to height, if you go to the CDC, Center for Disease Control's website, National Institutes of Health, they'll tell you that an average height in the country is 65 inches. So we're gonna put that number in here into test value. And
so the population mean goes into test value.
Right. And our sample mean that we're pulling from our class, that, you know, what we're interested in knowing is the class mean height statistically significantly different from the average height for the entire country. Okay. So then we're going to click OK. And we're going to come down here. And we're going to see a couple of things immediately, right? So we're going to see that we have 10 entries here, and that our mean height for our class is what? What is our average height for the class?
65.8 inches.
All right, good. And borrowing from the knowledge we got last week on standard deviation, someone tell me about standard deviation here. How many standard deviations that we have here from the mean?
2.39
inches, right?
Yes.
Mm-hmm. Good. And so you could extrapolate from there 2 standard deviations and 3 standard deviations above and below the mean. But the first thing we're going to go down here, we're going to go down here to the one sample t-test output here, right? And we're going to see here that the significance level is what?
0.318.
Is that higher or lower than 0.050?
Higher.
Higher.
Right. And we see here the 95% confidence interval of the difference crosses 0. The lower, if it ever crosses 0, then throw the test out. Okay, there's no significant difference. We can also tell that the significance value here being above 0.050 also invalidates any kind of significant difference. So what we would say here, and this makes sense, right? I mean, the mean height for our classroom is 65.8, and the national height was what? 65 inches. So there's not much of a difference there. And so what we would do is we would fail to reject the null hypothesis that, you know, we can't reject it because because the means are about equal. Okay. All right, it is 10:57. I'm going to do one more quick example. Dr. Chatiga is here, but I want to do one more example here. Let's take a look at weight in this situation. And we want to see if the national average weight is statistically significantly different than our class here, our Biology 101 class. So we're just going to do the same thing. We're going to go to Analyze. We're going to go to Compare Means. We're going to go to One Sample T-Test. And we're going to take height out, and we're going to put weight in. And what is our national average for weight?
I can't remember what it said.
184. 184.
Dr. Munn.
Yes, ma'am.
Okay. You said go to Analyze, go to Compare Means, and then I missed it from there.
Yeah, Analyze, compare means, then One Sample T-Test.
Okay. And then what we putting over there?
You're gonna put weight, into the test variable, because your that's coming over that's right here, the weight from your class.
Okay.
And we're testing that against the national average of weight. So we want to see if there's a statistically significantly difference between weight in our class, Biology 101 class, and the national average. And we simply click OK.
You have 184 in the test value?
Yes, ma'am. Because that is the national average weight.
Okay.
Mm-hmm.
Thank you.
No problem. So what we're going to come down here and see is that the mean weight here is 133, which is on paper much different than the national average weight of 184. And that makes sense. You know, if we're talking about a classroom, those are folk who are younger, right? And you know, as you get older, we all pick up weight. And the national average has to account for older population in the United States. So clearly, what we see here is just by glancing at the mean, we see that the mean weight for this classroom is much lower than 184. So then naturally we want to go here and see if this test holds, okay? And we go to the significance value and we see that significance value is 0.000, it's less than 0.050, right? So we know from the gate, this is good. This is very, very good. And so we see the mean difference is negative 51 pounds. And does the lower confidence interval cross 0 before it gets to the upper confidence interval?
No.
No. So that tells you that this model is significant. You know, so if we did this test again, what this is telling us is that 95% of the time that the mean difference, instead of being 51 pounds, it could fall as low as 60.5 and be as high as 41.4. And that's because the data set is small, right? We don't have a ton of cases here. But based off of what we do have, it is a significant difference from the national average weight. Okay. We will pick up here next time we meet for lecture, and we will go forth with paired samples, t-test, independent sample t-test, and then we'll go into one-way ANOVA. But at this time, I'd like to welcome Dr. Chitiga and turn it back over to you, and I will stop the recording.